Live. We're set there. Good morning. Good morning, everyone. So my name is Rachel Burson. I'm with the Robotics Institute, and I have two of our alums joining us today. I'm thrilled to have you both here. And what's exciting is I get to see you, hear about your experience and we get to share a little bit about the Robotics Institute and that we work together. So Seth and Rachel, in the last 10 days, I've heard from applicants that have specifically looked at your posters and your papers. So I'm excited by that. In fact, I had a conversation yesterday, Rachel, about the work that you did with Bassi last summer. So this is really cool because whether or not we know it, the things that we're doing, they're inspiring and connecting to others. And so, you know, the kinds of things like, I really want to see how I can work on this project or do that. That's super exciting. So what we hope to do today is to give a background on the Robotics Institute, RISS, talk about why to get into research, and I will give a quick overview of RISS. I'll turn it over to Seth and Rachel to share their experiences, and then we'll dive back in how to apply and some things there. Some of the top questions that we get are about how do I really shape my profile? How do I make sure that I'm putting my best application forward? So we're going to go ahead and dive in. I'm going to, I see I have a question in the background, so I'm just going to make sure, yep, we're all set. And we'll go ahead and get started. So again, my name is Rachel Burson. I'm with the Robotics Institute, and I've been working with the Summer Scholars program since 2006. So we have this generation really of scholars that have come through and through this experience been able to, it's all about launching into robotics and AI and just seeing what the future holds. So I'd like to invite Seth and Rachel to introduce themselves and to welcome. And I'm going to be joined throughout by Oscar, my cat over here, who has decided to visit for the session. So Rachel and Seth, would you like to welcome those that are joining us?
Sorry. Hi, everyone. I'm Rachel. I was with the cohort last summer, 2021. I am a senior at Winthrop University. I'm a CS and math major.
Hi, everyone. My name is Seth. I was in RISS in the 2020 cohort. And since then, you know, I've graduated undergrad, and I'm currently doing my master's in robotics here at Carnegie Mellon University.
That is so exciting. And we see that happen so often, is that the alums come through the program, or the students come through the program, they become alum, and they continue to collaborate, whether it's coming to the Robotics Institute for graduate school or going to graduate school elsewhere. We see those continued connections. And that's one of the things that is really important to the community. So I'm going to dive in and talk a little bit about the Summer Scholar Program. We were founded in 2006. So there's really, you know, part of a generation of students and emerging scholars that have gone through the program. And we'll get a chance to look at Seth's research, Rachel, and then also answer some of your questions. There's a separate link where folks are right now adding questions and such. So thank you for that. And throughout the session in the stream, I will add the I'll add that link so that you can ask your questions there. You can also upvote questions. So if you see a question, be like, oh yes, I really want to know that, then you can upvote that question. And the number one question is, what can I do in the next 30 days to make my profile and my application as strong as possible? So thank you for that. And Robotics Institute. So where are we? What is this? The Robotics Institute is at Carnegie Mellon University. This is actually the world's first academic department in robotics. And so when you're first, you get to really break ground and do a lot of innovative research, collaboration. And so there's so many ties around the robotics industry, around research that come back to Carnegie Mellon University and the work that we do here. A great example is autonomous vehicles and what has launched the number of companies that are really either founded by graduates of the Robotics Institute or their senior leadership is really highly, there's Carnegie Mellon graduates that are in highly represented there. So world's first PhD program. So we've been about research and education, really driving first from the research side and then making it accessible. What brings everyone together, there's 60 plus faculty members. There are so many different labs and centers, including the National Robotics Engineering Center, is that it is all about robotics, everyone that comes together. And one of the best ways I heard it described was one of the alums who said, the Summer Scholar Program is really curious students that are looking to explore, understand and robotics from all kinds of different angles. So I'll talk a little bit about what the program is, how we try to bring you into the program and what some of the goals are. It's really about exploration, learning, and growing. So you will be deeply connected to a specific research project and that guided research. There's a difference when we're in person and we're virtual. Summer 2022 is going to be in person. That is our plan to do so. So we're very excited about joining back into a live learning community. So the Summer Scholar Program is a learning opportunity. You contribute to a specific research project, but you're also learning about the research process. You are with a cohort of anywhere from 40 to 50 other students that are, some may be in the same lab, but most are going to be in other labs. And so within each cohort, you'll have somewhere between 15 to 25 labs. And so you get to explore those other labs, you get to hear about the research in there, and then to shape the overall program, there are so many different members of the community that are participating. So learning experience, the research, learning about research, actually contributing to research, and then the professional development. We want you to have, and Rachel and Seth know this, we were talking about communicating research results, and giving you an opportunity with us before you go into industry, before you go into graduate school, to think about how to powerfully present to a number of different audiences. And so each person that goes through the Summer Scholar Program, you'll have a chance to publish with us in the RI Summer Scholars Working Papers Journal, and we guide you through that. And there are workshops and tutors that are available. There's also, especially when we're in person, we'll visit a lot of labs and such. So we're looking forward to the return to that, going to some industry as well to see how they're approaching robotics and how they're solving problems. And all of that is really about the community. When we looked at the 2021 program, there were over 100 people that participated in some way in shaping that program, from mentors to workshop providers to presenters to tutors, to the administrative and business office to make that a possibility. So I'm going to pause for a moment and welcome Rachel and Seth to share their experiences with us. And to do so, what I'm going to do is to enable you to share screen if you'd like to as well, if you'd like to do that, or if you'd like to just kind of talk through your experience. Both are great, and we really appreciate hearing from you directly, because you know the program better than anyone. And while you're doing that, I'm going to dive into some of the questions so that when we come back, we can hear about some of the questions that people might have. Okay.
Okay, I can go first, Seth, unless you want to. Okay, so like I said, I was in the cohort this past summer. I worked in the air lab with Basti, Dr. Scherer. He's great. The whole air lab is really awesome. So I'll just start off by telling you guys a little bit about my research, because that's probably what you want to hear about. Okay, I have a abbreviated version of my presentation from this summer. Okay, there we go. So the really great thing about RIS is that you get to work on really, really cool projects. And the thing that I liked about my project a lot is that I got to try a lot of different things. It was pretty independent. I had as much support as I wanted to, but they also let me try a lot of different stuff, which I really loved, because one thing that I'm really curious about is multi-agent systems. And I always want to like work with that a little bit. And so they kind of let me, they gave me the idea, generally what we wanted to work on, and they let me kind of run with it. And I really liked that a lot. So what I ended up doing was working on a randomized algorithm for informative path planning for multiple UAVs. And in case any of you don't know what informative path planning is, it's basically if you have an environment with a set of nodes that you need to visit, informative path planning kind of figures out the optimal way to visit these nodes and maximize the reward. And what we would use that for is something like search and rescue. So with search and rescue robotics, they're becoming more and more relevant. We've used search and rescue UAVs already in situations like Hurricane Katrina to search wreckage for survivors and to check and see if buildings were structurally sound. So it's pretty big area right now. There's a lot of work being done in it. And informative path planning is a pretty big part of that, because if we're searching an environment, we need to be able to visit every node in an optimal way, because UAVs only have a certain number of like hours that they can fly because we have limited battery. And there was an algorithm that was developed before I got there. And what I was doing was trying to adapt it for multiple UAVs. And this is pretty much what I did this summer. I made this algorithm. So this is a very simplified version of it, but the way that it works is if we have an environment with a bunch of nodes in it, some of them are high valued, some of them are low valued. The high valued ones in this picture are represented by stars. And we have, this is an example with 2 UAVs. The way it works is we generate a random path through the nodes. And then after that, we just sample a random node. And if the node is not in the path already, we add it and we see if it makes the reward higher and it's still within budget. And if it does, then we add it. And then you kind of just keep repeating that over and over again. And the good thing about randomness is that it sometimes will grab nodes that you wouldn't grab in a regular algorithm. So randomness actually makes the reward a lot higher, a lot better. But yeah, so this is the algorithm that I spent most of the summer on. I did some other stuff too. There were small things with ROAR that we wanted to change. So I made modifications. I examined different environments where ROAR does really well. Because there are tons of algorithms for informative path planning. And one of the things that we were curious about was when the algorithm that we made would do well, because this was sort of a sub-project of a much bigger project for an actual UAV that they're making for search and rescue missions. So the really cool thing about this project to me was that it was a part of like a real search and rescue robot. And I thought that that was really cool. Here's an example of just my algorithm being run. This environment is kind of difficult for 2 UAVs because we've got 3 really high valued nodes that are far away from the other ones. And it can be difficult for algorithms like for standard informative path planning algorithms to run on this environment, because if you have a very limited budget, regular algorithms probably won't want to grab those nodes that are far away, but those are the ones that we want because they have the highest value. But with randomized algorithms, you can grab it pretty easily because, well, the randomized doesn't care that they're really far away. So that is a very, very brief overview of the work that I did at RIS. And as I'm sure you'll hear later, if you don't already know, you work throughout the summer with your mentor. Each mentor is different. But for me, I had, so there was Basti and he oversaw a lot of the interns, but you also get grad students too that help you. And I worked with Brady. So I'll go ahead and pass it over to Seth. I can talk more about it and answer questions if there are questions for me too.
That's great. Thank you, Rachel.
Sure, I can go ahead and get started. I've got a couple of slides to show. So feel free to send me any questions after the presentation at scarden@cs.cmu.edu if you have any more questions about riss or about my research in particular. So diving in, this is the why listen to me slide. What is my background, and why is it important, and how is riss really an integral part of what I've been able to do? And I started in riss in the summer of 2020. I worked with Professor Carnegie, who runs the human agent lab. And sadly, due to COVID, it was virtual. But despite being virtual, it was still a tremendous experience. And I learned a crazy amount about a new area of robotics that I was very interested in getting involved in. Previously, I had worked in a lot of kinodynamic path planning at my undergraduate university, but being able to be in riss really allowed me to transition my work to a new area of robotics using multi-agent reinforcement learning. Briefly, after finishing my undergrad, I did work as an applied scientist at Amazon's Robotics AI division, and lo and behold, the work that I did at riss was actually very influential at the work that I did when I was working in industry. Now I am back in academia working on my master's in robotics at CMU with Professor Carnegie. In my current work, I am working on human agent teaming, and in particular, the working title of some of my work that we're going towards paper right now is discrete sparse emergent communication for multi-agent reinforcement learning, where basically we're trying to develop a language between robots that can also be used when teaming up with humans to complete tasks cooperatively. But I digress, and I want to talk a little bit more about the research that I did as part of the riss program. In the riss program, I did what I would call a machine theory of mind approach to agent intervention. And what really is a theory of mind? There's a couple terms to go over here. Jargon gets crazy in each field, so it's good to define some things. And theory of mind is really like a belief state of another agent or human, software, or a real person. So when you think of a theory of mind model of someone else, we're really just trying to predict what it is that someone else will do. And in reinforcement learning, we would call that a policy. So we're trying to basically predict their policy. And not only do we want to know their policy, we have this notion of first order beliefs versus second order beliefs, because there's a first order belief that they have about their own the player's environment themselves, and then we really have this what we call a second order belief about what the player or person, human in this case, is doing. In this work, we looked briefly at how we can possibly create an expert agent in order to assist humans in performing a task. And we use an LSTM-based model in order to do this. So I think I'm just going to go briefly through these slides because it could be a lot here. But basically, in my work, what the idea is to do in two parts. One is to first be able to figure out when the human is performing suboptimally in some of our scenarios for search and rescue from data that we've collected. So one of the ideas we said, and one of the things that I was doing was I was going through and analyzing all these human-robot interaction trials with human data and seeing what is it that we could really be improving on. And the second part is how can I create an expert agent that will encompass some of the behaviors that were lacking in the human trial so that we can kind of assist the human with a reinforcement learning based agent. You can skip this. In the search and rescue environment, we model this in Minecraft, which is very interesting because you have a bunch of people who have never played Minecraft, a bunch of researchers who have never played Minecraft, doing research in Minecraft. I think that I definitely benefited in helping out the team because they would teach me reinforcement learning and I would teach them Minecraft. And I would explain why, like, for their experimentation, how we can help improve the experiments so that we can have more meaningful experiment with respect to, like, when you have a human playing this game, they have some sort of a load about how much they can think about. And we want to make sure not to overload them so that we can solve the task. But in order for the task to be solved effectively, it might be that there's just too much going on, too much to think about, that they aren't able to handle everything. Just because, like, the map may be very large and you don't know where everything is. And that's a case where we want to have a software agent remember, like, where the human needs to go. So we have these notion of victims that need to be saved, and some are high risk and some are low risk. And the idea is perhaps that the agent can remember the low risk victims while the human goes and rescues all the high risk victims. This is basically, we looked at the different trajectories that the human went through. This summarizes pretty much what they did, but we can skip this. This is nitty-gritty details. One of the main things that we found with respect to, like, the player's internal states were that we have intervention scenarios in three main types. One, triaging interventions, where triaging is rescuing. And the other two are terrain intervention and memory interventions. So in triaging interventions, this is because we may have the player be doing a greedy strategy. And while this may be optimal, as long as the distribution of the the distribution of the victims is such that the human can get to all of them. And when I say greedy, they mean they're rescuing first these yellow high-risk victims and then the green low-risk victims. But at a certain point, the human will not be able to rescue everyone because they may miss victims, or it'll become suboptimal when there isn't enough time in order to finish the problem. There could also be terrain issues. So we may have a floor plan of what the environment looks like, but maybe a floor collapse, or we're not able to go through a certain exit that we previously had planned to go through. So we have to now change our trajectory. And this is where using an agent would be very useful. And then the other one is memory interventions. And this is when a human may go through and just forget where they had previously visited. And in a second sweep scenario where you're going back through the entire environment, it's risky because you could be doing unnecessary searching when you've already been there before. You should already have a model of where these places are. And so one item is that we want to have a good memory for the human. And if the human it does not remember these things, we want to be able to help them. So we kind of modeled this in these mini grid representations where we have simple tasks where we're just trying to get to, let's say, this green dot that they're trying to find through. They have to open doors, and it gets more complicated and more complex with respect to perhaps not just doors, but there's also items in order to get from one place to another, so that we can solve a more challenging problem to show that an expert agent could be working in the environment with the humans. This is exactly what I'm saying. First, we use this very small, simple environment with, let's say, find a key and get to the door. And then we go to another environment, we say, now we have another task to do. And then we get this very, very complex environment that it models the human environments, where we have to not only do all of the above, we have to search this environment, find out where the area is. You have that sort of exploration of the environment to know what's there, but also triaging the environments. And this is exactly what the human is doing. Overall, we can find that just gonna skip ahead, actually, we can just look at this result. Overall, we find that the optimal performance occurs in most of the environments, but in the very, very most complex environments, we need a little more training in order to, with respect to less sparse rewards in order to solve this properly. Yep, we don't need to go through that. Thanks, everyone. Feel free to, like I said again, reach out to me over email if you have any questions. I'd be happy to answer anything about the program or about particularly the lab that I'm working with Professor Kadia.
You know what? Not planned, but what's amazing about today is that both of the labs that you connected with really have such a strong presence in UAVs, right? So drones, unmanned aerial vehicles, and their approaches to it. There's overlap in some areas, but some specific expertise there. The questions that are coming in that I'm seeing, again, there's a couple that, and I think Rachel and Seth will disagree. People are asking if I'm an international student, can I participate? Absolutely. So in each of your cohorts, there were international students, and we know being remote can be has been a lot of challenges. We'll work with you to apply for the right visa type to come to the U.S. If you're already in the U.S., then we'll work with you. There's just different paths to come and spend the summer with us at Carnegie Mellon. So we'll work with you on those specific issues there. There is one of the questions that came through and was raised up again is about, do they have to propose their own project, or are the project pre-planned, and how does that look? Each lab is different, as Rachel, as you were saying, each lab and I would say each scholar, because you're bringing a different background there. So I wonder if in our wrap up here, if you could speak to that question. What if you, now going through the process, if you looked back and you said, okay, here's the way to really prepare to figure out what projects are available first, and then how to navigate to a project that you're really interested. Seth, it looks like you're unmuted. Do you want to share your thoughts on that, and Rachel as well?
Sure. Yeah, I can take this question. So from my personal experience, before I talk about it generally, in the lab that I worked in, it's a large lab. And in large labs, a lot of times you'll be working with some of the graduate students, whether it be master's or PhD students, and you'll be helping them out. But if you do have the motivation and the guidance enough on your own internally, or something that you're so interested in, your advisor will definitely let you explore that area. A lot of this is self-guided. This is research. So self-guided and having that initiative is really important.
Sorry, I was muted for a second. I was going to ask Rachel, how does that resonate with you and your experience?
Yeah, I definitely agree. All the advisors are great. If you want to explore something, they'll let you. My advice as far as the application goes is to look at the past risk projects and talk about if you have experience in any of those areas, and if you want to extend on that experience in risk, definitely mention that. But I wouldn't recommend honing in on one project in your application and only talking about that, because you don't know who will be available. So you do want to show that you can do multiple things. But yeah, if you have a research question that you're curious about, you should definitely include that, because it shows that you are capable of doing research, even if you don't end up doing that project.
And that really resonates. To wrap us up today, I'm going to share screen here and go through really a slide and help focus in there. The research process is self-guided, the best thing you can do. And Seth spoke to this, Rachel spoke to this. Look at the prior research experiences that are within risk. Why do you do that? Well, these are scoped for the summer. They're specifically set up, and these are extensions. So if you're looking at what research has been done within risk in the past several summers, there's probably a possibility of extending that. The project may be in a different space or going in a different direction, or it could be very much along that line. So look at prior research, make sure that you go to the research showcase. You look first at the posters and the videos, then dive into the paper so that you understand. And Rachel, I think you also had a really good point of guidance there. It's like, it's better if you focus on not just one lab, but possibly multiple labs or projects, because that increases your chance of having conversations and finding the right fit. And part of risk is about finding fit, exploring different areas, and the mentors are delighted to dive in with you and engage and explore different areas. your starting point is looking at prior research and moving forward there. So application is we say fairly simple, but I think the statement of purpose and the preparation to apply is tough. We know that there's a lot that goes into it. So your resume is 2 pages or less. Your transcripts are unofficial. Your recommendation letter should be someone who can speak to your research potential. That could be someone that you've already done research with. It could be a faculty advisor that you've done an extended project with. And in your statement of purpose, you're going to talk about your interest areas. You're going to talk about your preparation and how you can contribute. You will be more successful if you identify projects that you show that you've done that homework, that you've researched, you've looked at what is going on at the Institute within the Summer Scholar Program. And if you also talk about contributing to a learning environment, because we're trying to set up an overall cohort and we value applicants that want to contribute and are going to be engaged in peer learning activities. So my best advice is to really dive in, look at the research showcase. So most successful applications, we find a direct connection. We find a direct connection that you've looked at that, and that can also motivate us to find other connections for you as well. So I want to thank Seth and thank Rachel. It was awesome to see you both today. And as I was saying at the beginning of the session, just in the last 10 days, there have been outreach and conversations about both your research. So, you know, it continues to inspire and to engage. And we really appreciated the opportunity to have the conversation. And Seth, thank you for inviting folks to reach out to you as well. And Rachel, we look forward to next steps together. We're all waiting to see pathways and what happens next. So thank you, everyone, and looking forward to